the area between a graph and the x-axis. In this example, we're going to use a method called the trapezoidal method. And what we're going to do is we're going to find the area between the x-axis and the graph, and the function is f of x equals to minus x squared plus 4. We're going to find the area between the x-axis and x equals to 0 and x equals to 2. And what we're going to do is we're going to draw trapeziums now, and the trapezium will have a width of half a unit because the question says use the partition where p equals to 0, half, 1, 1.5, and 2. Now let's just first, before we start, recall that the area of a trapezium equals to half the sum of the parallel sides times the perpendicular distance between the parallel sides. So once again, what we're going to do is we're going to draw trapeziums, and the trapezium must be a width of half a unit. So I'm just marking off half a unit on the Cartesian plane. And now we're going to draw the trapeziums. So I start at x equals to 0, and that would be one of the parallel sides of the trapezium. I draw another line parallel to the y-axis at x equals to half, and that is my first trapezium. My second trapezium will be at x equals to 1 and at x equals to a half, and that's my second trapezium. My third trapezium is at x equals to 1.5, and my last trapezium will be at x equals to 2. So the side of that trapezium would be there. The next step is to work out the corresponding y values. So at x equals to 0, I'm going to work out what is f of 0, and I see that f of 0 equals to 4. I will read this off the graph, or what we could have done is substitute it into the equation. Now we're going to find f of a half. So f of a half will be minus a half squared plus 4. So when x is a half, the y value is going to be, this gives me minus a quarter plus 4, which is 3.75. The next value I'm working is f of 1. So that is minus 1 squared plus 4. So we can read this value off the graph. We see that f of 1 equals to 3. I continue and I find what is f of 1.5. So substituting into the equation, it's going to be minus 1.5 squared plus 4, and f of 1.5 is 1.75. And the last substitution is going to be f of 2. So when x is 2, we see that f of 2 is 0. We read that off the graph. We could have also calculated by substituting 2 into our equation. So that gives me minus 4 plus 4, which is 0. So I have 4 trapeziums in my diagram. I'm just going to scroll up to show you again the 4 trapeziums that we drew onto the diagram. And what we're going to do now is we're going to calculate the area of each trapezium. So if we look at the first trapezium, we're going to find the area of trapezium 1. So the parallel sides is at x equals to 0 and at x equals to half, because these are our parallel sides. And the formula says that the area of a trapezium is half the sum of the parallel sides. So I have to find the sum of the length of the side at x equals to 0 added to the length of the side at x equals to a half. And then I must multiply it by the perpendicular distance between the parallels, and the perpendicular distance between the parallels is actually the width of your trapezium, and in each time it is going to be half a unit. So let's work out area 1. So area 1 is going to be half the sum of the parallel sides. That means What is the y value at x equals to 0? So it's going to be f of 0 plus f of a half multiplied by the perpendicular distance between the parallels, and in this situation it is a half. So it's going to equal to a half. Right, we have already calculated that when x is 0, y is 4, so the length of the first parallel line is 4 units. The length of the second parallel line at x equals to a half, we have worked out, is 3,75 units. And this must be multiplied by the perpendicular distance between these two sides, which is the width, which is half a unit. And when we calculate this, we see we're going to work out, so a half multiplied by a half gives me a quarter, and quarter must be multiplied by 7,75. So the first area, or the area of the first trapezium, is 1,935 square units. Using this method, I'm now going to work out the area of my second trapezium, and I'm going to call that area 2. So area 2 is again going to be half the sum of the parallel sides. So the first side is at f of a half, so it's going to be f of a half plus f of 1, the sum of the lengths of those sides multiplied by the perpendicular distance between my two parallel sides, which is the width, which is a half. So once again, a half times a half gives me a quarter. The y value when x is a half, we've worked it out to be 3,75. And the y value when x is 1, we worked it out to be equal to 3. So this is going to be a quarter of 6,75, which gives me 1,685. Sorry, it's 1,6875. I am now going to find the area of trapezium 3. Trapezium 3 lies between x equals to 1 and x equals to 1,5. So therefore, area 3 is again going to be half f of 1 plus f of 1,5 multiplied by a half. So it's going to give me a quarter. We know that f of 1 is 3,75. And if we scroll up, we see that f of 1.5, when x is 1.5, we see that y is 1,75. So it's 1,75. And so that the area of my third rectangle is going to be 1,1875. Sorry, my third trapezium, because we're doing the trapezoidal method, is 1,1875. We now work out the area of the last trapezium, and that lies between x equals to 1.5 and x equals to 2. So the fourth area, sorry, let's just redo that. So area 4 is going to be half f of 1.5 plus f of 2 multiplied by the width, which is a half. So a half times a half gives me a quarter. The y value at x equals to 1.5 is 1,75. The y value at x equals to 2 is 0. And this gives me 0,4375. So once again, the total area is going to be the sum of the areas of the 4 trapeziums. So it's area 1 added to area 2 added to area 3 plus area 4. So it's going to be 1,935 plus 1,6875 plus 1,1875 plus 0,4375, and if I add up, I see that the area in total is 5,25 square units. So we have found that the area between x equals to 0 and x equals to 2 using the trapezoidal method is 5,25 square meters. And can you see that the trapezoidal method is more accurate approximation of the area under the curve between the x-axis and the graph minus x squared plus 4. Because of the wasted space, if I may put it that way, is so much less than with the rectangular method. I'm now going to continue and just show you a shorter way of working out the area of the 4 trapeziums. So if you notice, the area 1 was half of f of 0 plus f of a half times the width, which was a half. Area 2 was half of f of a half plus f of 1 times the width, which is a half. Area 3 was half of f of 1 plus f of 1 and a half times a half, and we continue in this way. So we can also write down the formula all in one step. So our area, or our total area, is a half the sum of the parallel sides. So for area 1 we had f of 0 plus f of 1. In area 2, let me just scroll up and show you what I'm saying. In area 1 we had f of 0 and f of a half. In area 2 we had f of half plus f of 1. Can you see that f of a half is repeated? In area 2 we found f of 1, and we needed f of 1 in the third area as well. So f of 1 is repeated. And if you scan, you can see f of 1 and a half is repeated, and then we had to find f of 2. So we can write the formula as f of 0 plus 2 f of a half plus 2 f of 1 plus 2 f of 1 and a half plus f of 2 times my width, which is a half. I'm going to write it here underneath. And then I substitute my values. So I know, and I've calculated, that it's a half, or you can even multiply a half times a half can give you a quarter, but I'm going to write it as a half. When f of 0, what was f of 0? We worked out that f of 0 had a value of 4. We worked out that when x is a half, y was 3,75, so we need to multiply that by 2. We worked out that when x is 1, f of 1 is 3. We know that f of 1 and a half was 1,75, and we know that f of 2 was 0, multiplied by the width, which is a half. And if you calculate this, you get 5,25 square units.